solving one-step addition and subtraction equations. Okay, so first couple things that I have written down here for you. It's not super important that you necessarily memorize these, but there's some terms in here, some vocab in here that we need to make sure that we know. The addition property of equality. So we're looking at this first definition right here. The addition property of equality says that adding the same number to each side of an equation produces an equivalent equation. Okay, equivalent is a fancy mathematical term for the same. Okay, so if we add the same number to each side of an equation, the equation remains the same. Okay, the subtraction property says the exact same, except we're talking subtraction. Subtracting the same number to each side of an equation produces an equivalent equation. Here's what this means, guys. Here's what this means. So, for example, if we have, you don't necessarily have to write the definitions down or any of this down. I just kind of want to show you what I mean here. For examples, how about for example? There we go. For example, if, this is going to seem silly, if 5 equals 5, that's an equation. It's a true equation. It's a very simple equation. If 5 equals 5, the addition and subtraction property of equality that we saw up at the top says that, then that means if I add the same number to each side of the equation, let's say I add 2 to both sides of the equation, I still have a true equation. Okay, adding this 2 to both sides of my equation doesn't change the value of the equation at all. Okay, it still gives me a true statement. 5 plus 2 is still equal to 5 plus 2. And then same thing with subtraction. That means that, I don't know, 10 minus 2 is the same thing as 10 minus 2. Okay, so on and so forth. Okay, so I should put here, if 10 equals 10, then that means 10 minus 2 is going to equal 10 minus 2. If I subtract the same thing from both sides of my equation is not going to change. I still have an equivalent equation even if I subtract the same number or add the same number from both sides. Okay, so again, it's not super important that you necessarily memorize the exact definition of what these properties say, but just the concept of adding and subtracting the same thing from both sides of your equation does not change the value of the equation. Okay, this down here, super important right here. This, we're going to be solving equations for a little while here. This is important down here. The goal for solving an equation is to isolate the variable. Isolate. You should know what isolate means. It just means get it by itself. Get the variable by itself. Isolate the variable using inverse operations. Inverse operations, what that means, the inverse of addition is subtraction, and vice versa. The inverse of multiplication is division, and vice versa. We're using inverse operations. We're going to try to undo things to get the variable by itself. So let's go ahead and get down to business here. So let's go ahead and write these down. Hopefully you have a notebook or a whiteboard or something in front of you that you can write things on. The first problem, first equation we're going to do is x minus 7 equals negative 6. X minus 7 equals negative 6. So the first thing that I like to do when I first start an equation, I like to draw a line down my equal sign, and that's going to separate it into two sections of my equation. Okay, here's what we need to do. We need to get x by itself. We need to end up with x equals something. X equals our solution. So to do so, I need to get rid of this minus 7. So right here, I need to undo this subtraction, okay? I need to undo the subtraction. I need to get rid of that minus 7 so I can just be left with x. So we just learned on the last slide that why don't I just add 7 to both sides? Because adding the same thing to each side of my equation does not change my equation. That's how we're going to get x by itself. By adding 7 over here on the left, it's going to undo the subtraction of 7. Okay? So that's going to leave me with my x by itself. And my solution is whatever negative 6 plus 7 is. Negative 6, think of negative 6 on a number line, you're moving up 7 units. That's going to result in an answer of positive 1. So x equals 1. So basically we're looking at, okay, what are you doing to the variable? in the original equation, whatever you're doing to the variable, you need to undo it and get the variable by itself. Okay, so let's try the next one. Next one I have 1 equals w plus 6. Okay, I'm going to start by drawing a line down my equal sign just to split up my equation a little bit. So I'm going to look at my variable, and it looks like I'm adding 6 in the original equation. So I need to undo the addition right here, okay? I need to get rid of that plus 6. I need it to be gone. Okay, so like we learned on the first slide, the subtraction property of equality, if I just subtract this 6 from both sides, it will cancel out the plus 6, and it will leave me with w by itself, so that's the goal there, and 1 minus 6, which is negative 5. And that is my solution. And remember, for all of these, test your solutions, see if it works, okay? So for example, for this first equation here, for x equals 1, is 1 minus 7 negative 6? Yes, so I know that my solution is right. For this solution here, for part B, is 1 equal to negative 5 plus 6? Yes, negative 5 plus 6 is 1. So that is the solution. I got the correct solution. I know that I'm right. Okay? Last one we're going to try. I'm going to throw some fractions at you, our favorite. So I have t minus 1/4 equals 5 halves, 5 over 2. Okay, so here's how I'm going to tackle this. I'm not going to write my line quite yet. I am going to rewrite my equation with a common denominator. Okay? Because I'm going to be needing to do some adding and subtracting here. I know when I see this minus 1/4, t minus 1/4, I know, okay, I'm going to add 1/4 to both sides to get rid of the minus 1/4. I'm going to be adding fractions here. Whenever we add and subtract fractions, we have to get a common denominator. Okay? So 5 halves. We should hopefully know how to find common denominators. I'm going to use a common denominator of 4. I'm going to leave 1/4 as 1/4. 5 halves. See if you can figure out what 5 halves is in terms of fourths. Okay? If I double 5 halves, that's going to give me 10/4. Okay? 10/4. So my equation hasn't changed. I've just rewritten this 5 halves here with a denominator of 4. So 5 halves has the same value of 10/4. I've got a common denominator, so let's go ahead and start to solve. So I am going to undo the subtraction. Okay, so I don't want that minus 1/4 there. I need to undo the subtraction. Okay, right here. Undo the subtraction. So to do that, just like the last few examples, I'm going to add 1/4. Add 1/4 to both sides. That's going to cancel out the minus 1/4. It's going to give me my variable by itself. So remember, that's the goal, is to get the variable by itself. Got to undo everything being done to the variable. So my final answer will be whatever 10/4 plus 1/4 is. Again, see if you remember how to do this. Go ahead and see if you can figure out what 10/4 plus 1/4 is. Should be 11/4. Just add the numerators, keep the denominator. That's it. Leave your answer as an improper fraction. I do not want mixed numbers anymore. We don't need to worry about that. Okay? All right. Let's move on. I got one more problem for you guys. Second example. This is the last one. A discounted concert ticket costs $14.50 less than the original price P. You pay $53 for a discounted ticket. Write and solve, this is very important here, write and solve an equation to find the original price of the ticket. Okay, so let's think about what we have here. Here, let's get all of our information. $14.50 less than the original price P. So I have a price of a ticket. It's discounted by $14.50, and it gives me a value of $53 for the discounted ticket. So here's the deal. I bet a lot of us could just think mentally and figure out this answer, which is fantastic. I hope that you can. I hope that you can just read this and be like, oh, cool, the answer is blah, blah, blah. But it's really, really, really important to be able to take the information that we have in this problem and write it and model it as an equation. Okay, I know it might seem like a little bit of extra work, like, well, I can just figure it out just by thinking about it. I know, that's good. I'm glad that you can. But let's try to write an equation that would represent this current situation. So our equation, I have the price of a ticket. I don't know how much the price of the ticket is, okay? But I am going to subtract whatever the discount of that ticket is, and that's going to give me the discounted price, right? Discounted price, right? Doesn't that make sense based off of the problem that we see above? I have the price of the ticket, I'm subtracting the discount, and now I have the discounted price of that ticket. So let's fill in the information here. I don't know the price of the ticket. The variable that was assigned is P. So I have P minus the discount. Well, it says right up there, the discount was $14.50. And that gives me the discounted price. The discounted price stated in the problem above is $53. So I have some price of a ticket. I'm subtracting $14.50 from that price, and I'm getting to a value of 53. Okay, so let's go ahead and solve this. I want to get P by itself. All right, that's the goal here. So I'm going to use inverse operations. I see a minus 14. I'm going to undo, or I'm sorry, minus 1450. I'm going to undo the subtraction by adding 1450 to both sides. Okay, so my 1450s cancel out. That's the goal. And I'm left with P equals 53 plus 1450. What do we got then? 6750? So the price of the original ticket is $67.50. There we go. Okay. All right. So just be careful with word problems like this, because I would be willing to bet that some of you guys might have already tried to solve this right off the bat and do it mentally, and you saw less than, and you saw $53. You said, oh, less than means to subtract. So I'm just going to do 53 minus 1450, and I'm going to get, what, 3850? Okay, but when we write it as an equation, we can quickly see that we're actually not subtracting 53 and 1450. We are adding 1450. Okay, so take your time, represent the problem in an equation, and it will help you keep your thoughts organized and help you land at the correct solution. Okay? All right, that's it for this video. I will see you next time.